So in this section, guys, you will learn how to test the difference between two proportions. For example, I claim that the percent of women who shop online is more than the percent of men who shop online. This is an example of two sample proportion that this section will cover. So it's all about percents. How to perform, it's a two sample proportion test between two population proportions, P1 and P2. And here are the conditions of the test. The samples must be randomly selected. Always random is important, guys. The samples must be independent, and the samples must be large enough to use a normal sampling distribution. Here's the conditions. So we have to verify that N1 P1 is greater than 5. P1 is probability of success. Q1 is probability of failure. N1 Q1 is greater than 5. N2 P2 greater than 5. And N2 Q2 is greater than 5. So in order to run a two sample proportion test for the difference between two proportions, first of all, you have to verify the conditions of the test. And then look, guys, nothing new. State HO and HA and identify the claim. I will add this. Calculate the test statistic Z. Calculate the p-value. Make a decision to reject or fail to reject HO. Interpret the decision in the context of the original claim. Together, probably now we can fill out this for the proportion. So first choice equal. Just like the mean, guys. You just choose one of three. You don't have to reinvent anything. P1 greater than or equal to P2. P1 is less than P2. And here, P1 is less than or equal to P2. Same thing with the mean, guys. Just it's changed the mu1 and mu2 to P1 and P2. All right. And let's go to an example right away. You ready? So that's the first question. In a study of 150 randomly selected occupants in passenger cars. So we have here passenger cars. $150, so N1. And 200 randomly selected occupants in pickup trucks. %86% of occupants in passenger cars and 74% of occupants in pickup trucks wear seat belts. Actually, when we did the proportion, guys, in chapter 7, you need two values in order to run the proportion test. You need N and you need X. X is the number of successes. But here he didn't give you X directly. He gave you P1 hat and P2 hat, a proportion. So 86%. And here he says it's 74%. 86% of what? It's 86% of the 150. And 74% of what? It's 74% of the 200. So in order to find X, guys, the X1 and X2, in chapter 7, we had one sample. So you had one N and one X. Now you have two samples. So you're going to have N1, N2, X1, X2. Here's how you find X, guys. You just take N and multiply it by 0.86. And here you take N and multiply it by 0.74. Just change the percent to a decimal. This is the P1. hat, P2 hat, and this is the P1. Okay, let's see what the result is. So 150 divided by 0.86. You can do that with me. Sometimes he gives you X, other times he doesn't. This time I just didn't give you X directly. It would have been easier if I gave you X, but you will see in the next problem, probably we did give X. So that's 129. And for the second one, guys, 200. 148. At alpha equal 10%, can you reject the claim that the proportion of occupants who wear seat belts is the same for passenger cars and pickup trucks? Okay, guys, can you tell me which one we're going to use for HO and HA? First, second, or third? Can you reject the claim that the proportion of occupants who wear seat belts is the same for pickup trucks and passenger cars? What does is the same mean, guys? What sign?
Not equal to.
Yeah, it's going to be this. Just have to have common sense, guys, and just read it. And the claim is an HO this time. That's why he didn't say, can you support the claim? Can you reject it? Remember, we always try to work against HO. So if the claim is an HO, we'll try to reject it. We don't favor it. Always we try to stay away from HO. Okay, so P1 equals P2. Now you ask me probably, how do we know we have to put mu1 and mu2? Well, he says a proportion, guys, so we better be P1 and P2. Okay, look right here. And actually, if this question was about the mean, guys, he have to give you an average X1 bar and standard deviation. There is no average here. It's just N and X, N and X. Okay, so it's a two-prop Z test. That's the new test. So far in chapter 8, guys, we've gone through the following tests. Excuse me. We did number 3. We did number 4, and now we're doing number 6. You can see it right here. You did number 5 in chapter 7. You did number 1 and 2 in chapter 7, and now we're doing a 3, 4, 5, and 6, and now 6, section 8.4. And you guys, you can see we did 7 in chapter 6, we did 8 in chapter 6. We're gonna do almost all of them by the end of the semester. Okay. X1, this is a 129. I just have to warn you guys, if this, when you multiply, turns out to be decimal, you have to round it to the nearest whole number, because X1 is number of successes, is discrete, can't be decimal. So make sure to round it. But we didn't need to round it because it turned out to be 129. N1 is 150. X2 is 148. 200. Not equal to, look guys. That's the alternative sign. And that's it. Calculate or draw, it's up to you. I'm fine either way. So Z is 2.73, and look at the p-value, it's very low. When you don't see any shading here, guys, barely any shading, just reject HO. So 2.73. Again, guys, I cannot emphasize enough on asking you to, when we're done, just go back and redo those problems. Make sure that you can do them after I've done them. I know it might make sense to you at the moment, but in order to retain this information, you got to do it yourself. And you got the answers. You got the answers in front of you guys, so that should be very, very helpful. P-value is less than alpha. Whatever alpha, I don't care even what alpha is. Reject HO. Okay. Remember, the claim is in HO and we reject HO. So what do we say here? There is enough evidence at a 0.10 level of significance to, who can tell me what's a word here? We have enough evidence to what? To reject the claim or support the claim? What do you guys think? We rejected HO and the claim is in HO. So we end up what? Rejecting the claim. There is enough evidence at the 0.10 level of significance to reject the claim. And the claim is that the proportion of occupants, proportion means percent, that the percent of occupants who wear seatbelts is the same for regular cars and pickup trucks. And be honest with you guys, I don't think it is the same. People who drive pickup trucks are more inclined not to use a seatbelt because they think that they're safer. They drive a big vehicle, so they feel like a more sense, of safety than if someone was driving a small car. So I think I can bet you that people who drive smaller cars are more inclined, just to keep the seatbelt on, while drivers of big vehicles, probably not. And that's what we say. We say we reject the claim that the proportion is the same. It's not the same. I think it's bigger for the ones who who drive passenger cars than pickup trucks. So that was the first question. Okay. That's section 8.4, and that's the number. Now, if we are to verify, if he asks you guys in the homework to verify the conditions of the test, here's how you verify the conditions of the test. Look, take N1 and multiply by P1, which is 129, that's bigger than 5. Then you have to take N1 and multiply by Q1. If the probability of success is 86%, guys, the probability of failure is 14%. So you just take 0.14 and multiply by 150. Oops. Bigger than 5. Now you take 74% and multiply by 200. You already did. It's 148, bigger than 5. Now, if P2 is 74%, what would be Q2? 100% minus 74, which is 26%. Take 0.26 and multiply by 200. Bigger than 5, conditions of the test are met. If he doesn't ask you to verify the conditions of the test, then you don't verify him, but only if he asks you to verify the conditions of the test. Okay, next question. Okay, let's do this exercise. That's section 8.4 again. A medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researcher found that of the 4,700 randomly selected subjects who took the medication, 301 died of heart disease. So look, medication, and probably the other one, no medication. Placebo. See, it's all real life situations that you're learning now. So N1 is 4,700. X1, he didn't give me a percent, so that's good. He just gave me X301 died. Of the 4,300, and now N2, who took the placebo water pill or sugar pill, 357 died. Here's the question. At alpha equal 1%, can you conclude that the death rate due to heart disease is lower for those who took the medication than for those who took the placebo? So can you guys tell me which one is it gonna be? He says, can you conclude that the death rate is lower for the ones who took the medication than the ones who didn't? What does lower means, guys? What does lower mean? Yes?
Less than.
Okay, so which one is it gonna be? Number one?
Number 2.
Number 2, very good. That's all I need. Don't make it hard, guys. I'm trying to simplify this process as much as I can. Trust me, it's not difficult. Just follow the procedures. You have to follow the procedures. That's very, very important. You cannot skip any of the steps. All right, so 2 proportions test, z-test. Okay, let's do it. Just put the z here. Okay, x1. X1 is always a smaller number, guys. So the 301, if you mix it up with N1, the calculator will halt. Let me just do it. You're gonna see that it's gonna be a mistake here. It's not gonna process it. Let's say, so don't write this down. We're doing less than. Watch. It says invalid domain. So you just go back and fix things. The X1 should be 301. That's 4,700. And X2 should be 357. And that should be 4,300. And now everything else is good, guys. So Z is negative 3.46 to 2 decimal places, and p-value is 3e minus 4. Let me tell you what that means. This is the decimal point here, guys. Move it for decimal. So it will be 0.0003, which is of course less than alpha. You don't even need to look at alpha. That's a very small number. So you reject HO. All right. And you reject HO. What do you say? There is enough evidence at the 0.01 level of significance to support the claim. I could use the word conclude instead of support because it says, can you conclude? It didn't say, can you support? Well, it doesn't matter. That the death rate, I'm just copying the language, guys, due to heart disease is lower for those who took the medication. Than for those who took placebo. That's how they do experiment, guys, to study the effectiveness of a new medicine or treatment. They bring two groups. One is called the control group that takes sugar pill, the placebo. This is called control group. And the other one is called the treatment group that takes the actual, just medication, whatever they're trying, just out, like in the case of COVID-19 vaccine. There were two groups. One group did not get vaccinated and the other one got vaccinated, and they compare the results. If you can reject the null hypothesis, then the results are effective. That means the medication is effective. If you cannot reject the null hypothesis, then the medication is not effective, because the null hypothesis says P1 could be equal to P2 or greater. So that means probably the medication is not effective. Here, the death rate is lower than the death rate for the ones who took the placebo. That means the medication is effective in lowering the death rate. Any questions here? Okay, I want to do one more exercise in this section, guys. So let's do just let me pause for 1 second. In a survey of 500 doctors that practice specialized medicine, 20% felt that the government should control healthcare. So this is N1, guys. But he didn't give you X1. He gave you the percentage. What I told you guys in the previous exercise to do, just take the percentage and multiply it by N to get to the X. So that's a P1 head. Felt that the government should control healthcare. In a sample of 800 doctors that were general practitioners, 30% felt that the government should control healthcare. So that's N2. I'll write them down separately in a second. And this is P2 head. Test the claim that there is a difference in the proportion. I don't think, guys, you should be confused here. When it says there is a difference, that's what he's asking you to test. So look, P1 equals P2, P1 not equal to P2, and that's the claim. Excuse me. And here we have N1 is 500, P1 head is 20%. And look, guys, X1, you can do it right away. X1 is 20% of 500. 0.20 times 500. Excuse me, guys. N2 is 800. P2 hat is 30%. And X2 is going to be the 30% times the 800. All right. So it's a two proportion z-test. I'll leave the screenshots for you, but let's do it together. Okay, X1. You could do this before, or you could do it just right here if you want, 0.20 times 500. It doesn't matter, guys. But make sure it is a whole number. N1 is 500. X2 is 0.3 times 800. N2 is 800. And P1 is different from P2. That's what we're trying to test. All right, so, all right, and then let's hit the draw. All right, so Z is negative 3.99. And p-value is 1e minus 4. The p-value, guys, is just to interpret it. Means 0.0001, which is less than alpha. We reject HO. And if you reject HO, you say there is a difference. There is enough evidence at the 10% level of significance to support the claim. What is the claim? The claim that there is a difference in the proportions. So we can support the claim, and you can strongly support the claim. The smaller the p-value, guys, the more evidence, the higher the evidence against HO. And look, this is very, very small. But when the p-value is close to alpha, the results probably are not very significant. So reject HO and support the claim. So that concludes, guys, section 8.1.